If we have two parallel lines, I already told you the two parallel lines will have the constants A and B same, only the difference is the constant C. The distance formula is given by C1 minus C2 divided by root of A square plus B square. So when I say x-axis, any point on the x-axis is always in the form of x, 0. That means your y coordinate is 0. Hello everyone, a warm welcome to one and all. This is your Shruti ma'am lecturing in Vidyashram, the Temple of Excellence, Mysore. So in our previous session, we have learnt about the formation of equation of line as well as the transformation of general equation into various other form. In this session, we are going to study about the distance of a point from a line as well as the distance of two parallel lines when a line and a point is given. So consider a straight line here with respect to the x and y coordinates. So let us consider a point P here, somewhere here. So the distance of any point to the given line is always the perpendicular distance. So anywhere, here if you consider a point, then this distance, the shortest distance is always the perpendicular distance between the point and the line. So that distance is the line segment between the point as well as the line. So similarly, we can also calculate the distance between two parallel lines. We know that distance between two parallel lines is again a perpendicular distance and it is always constant throughout any point on the two lines. And thus, this distance D is given by the formula ax1 plus by1 plus c divided by square root of a square plus b square. So here, what is a, b, c? So if the general equation of the line is ax plus by plus c is equal to 0 and we have a point P here whose coordinates are x1, y1. And this point, if you substitute in the standard equation of the line, divided by the square root of the sum of square of a square plus b square will give you the distance of a point from the given line. So it is modulus with respect to modulus because we know that distance is always positive. So even though if you get a distance in the form of negative, you need to convert it into positive. So this formula D is equal to ax1 plus by1 plus c divided by root of a square plus b square represents the formula to find the distance of a point from the line. So next we have distance between the parallel lines. So if we have two parallel lines, I already told you the two parallel lines will have the constants A and B same, only the difference is the constant C. So therefore, if AX plus BY plus C1 represents one line, AX plus BY plus C2 represents the other line which are parallel to each other, then the distance between them is given by D is equal to C1 minus C2 divided by root of A square plus B square. This can also be interchanged. We can also write it in the form of C2 minus C1. Since we have modulus, it doesn't alter any changes here. So therefore, it is always given by C1 minus C2 divided by root of A square plus B square. Find the distance of a point 3, minus 5 from the line 3x minus 4y minus 26 is equal to 0. So first write the formula D is equal to ax1 plus by1 plus c root of a square plus b square and the modulus. So now what is a, b, c? A is 3. B is minus 4, C is minus 26. So let's write A 3, B minus 4, C minus 26. X1, Y1 is the coordinates. So X1 is 3, Y1 is minus 5. Substitute all the variables here. Then we'll get 3 into X1, 3. Plus B is minus 4, Y1 is minus 5. C is minus 26 whole divided by A square is 3 square, B square is minus 4 whole square under the square root. So next we have 9 plus 20 minus 26 whole divided by 3 square plus 4 square. 9 plus 16 is root 25. Next we have 29 minus 26, which is equal to 3 divided by square root of 25 is 5 units. So therefore the distance is 3 by 5 units. Next one, find the distance of a point minus 1, 1 from the line 12 into x plus 6 is equal to 5 into y minus 2. First let us reduce this in the standard form. So let's multiply 12x plus 72 is equal to 5y minus 10. So then we'll get 12x minus 5y plus 82 is equal to 0. So A is equal to 12, B is equal to minus 5, C is equal to 82. Here x1 is equal to minus 1, y1 is equal to 1. So now the distance formula is given by D is equal to Ax1 plus By1 plus C whole divided by root of A square plus B square between the modulus. Substitute here 12 into minus 1 minus 5 into 1 plus 82 whole divided by 12 square plus minus 5 whole square under the square root. So next we have 12 minus 5 plus 82. So this is minus 12 whole divided by 12 square is 144, 5 square is 25. So we get this as root 169. So next we have 82 minus 12, which becomes 70, and minus 5 becomes 65. So 65 divided by 13. Now if we cancel this, we'll get this as 5 units. So therefore the distance is 5 units. Next question. Find the points on the x-axis whose distances from the line x by 3 plus y by 4 is equal to 1 are 4 units. So we need to find out the coordinate on the x-axis. So when I say x-axis, any point on the x-axis is always in the form of x, 0. That means your y coordinate is 0. But we need to find out x there. But I don't know whether the line x is touching the line after the y-axis or before the y-axis. That means whether the coordinate is positive or negative. But here they have given the distance of a point to the line is 4 unit. So D is equal to Ax1 plus By1 plus C divided by root of A square plus B square is written with the modulus. Now since we don't know what is the coordinate of x1, we can take the distance as plus or minus 4, removing the modulus. So now let's write the intercept form of the equation to the standard form and find A, B, C. So here they have given x by 3 plus y by 4 is equal to 1. If we write this, we'll get 4x plus 3y is equal to 12, or 4x minus 3y minus 12 is equal to 0. Now this is the general equation. So now value of A is 4. I don't know what is x1. Let me keep x1 as it is. Value of B is minus 3. Y value will be 0 because we are finding the point on x-axis. So therefore here I can take it as 0. Value of C is minus 12. Whole divided by 4 square minus 3 square. So now here plus or minus 4, 4x1, this becomes 0, minus 12, this is under the square root, whole divided by 16 plus 9 root 25, which becomes 5. Now cross multiply here, we'll get plus or minus 20 is equal to 4x1 minus 12. So now we can write this as 20 is equal to 4x1 minus 12, or minus 20 is equal to 4x1 minus 12. Let's solve them. We'll get 4x1 is equal to 32, or x1 is equal to 8. So therefore the point can be, or x1 comma 0 can be 8 comma 0. And here we have 4x1 is equal to minus 8, x1 is equal to minus 2. So therefore, according to this, x1 comma 0 can be minus 2 comma 0. So therefore, the line may intersect the x-axis at the point 8 comma 0 or minus 2 comma 0. Next one, find the distance between the parallel lines 3x minus 4y plus 7 is equal to 0 and 3x minus 4y plus 5 is equal to 0. So the distance formula is given by c1 minus c2 divided by root of a square plus b square. So c1 is 7 and c2 is 5, so minus 5 divided by 3 square plus minus 4 whole square under the square root. So which is 2 divided by 5 units. Next one, find the distance between the parallel lines 15x plus 8y minus 34 is equal to 0 and 15x plus 8y plus 31 is equal to 0. The same formula, d is equal to c1 minus c2 divided by root of a square plus b square. So c1 is minus 34, c2 is 31, 15 square plus 8 square under the square root. So we have here minus 65 whole divided by 225 plus 64, which is 289. Now we get minus 65 divided by 17, or we can write this as 65 by 17 units. So this is the distance between the given parallel lines. So thus we have completed all the concepts in the straight line chapter. I'll meet you in the next session. Until then, keep watching, keep learning and keep exploring. Thank you.